desert, hot, dry weather. And then we have temperate climates like India and Australia, where you have a combination of both hot, dry, and monsoon seasons. So you want to separate these interiors from all of these various conditions. So you needed to know what those conditions are. When you look at the building enclosures, previously we had just one layer of brick, and that was it. In some cases, we would see in India, there's huts that are built with just clay or cement walls or brick walls alone. There's no other layers. When you look at the wall sections in the North American climate conditions, you're going to see about 6 to 8 layers of construction here. And it all starts with a structure, because you have to have a structural component. And then from the structure, you build outward by protecting it from wind, rain, and water. So there is a water barrier, there is an air barrier, there is an insulation, and then an exterior cladding system. You see at least 4 or 5 different layers outside of the structure. On the inside, you will see gypsum board. In the houses, you often see that when you knock, they're on wood or a gypsum board. The gypsum board is actually providing the fireproofing, which is a 1-hour fire rating. Whenever a fire hits that wall, up to 1 hour, the fire will not propagate from that surface. So anything that is really lit in fire, they cannot stop it. But if a fire or flame comes close to any of those surfaces, they're not going to catch fire as quickly, unless you have a wallpaper or something that becomes a concern. So you have to consider all of the functions of the room and then the types of structures before you select what other components that you can integrate with it. In a similar way, the roof has roof deck, and then you have insulation, and you have a waterproofing layer here called an EPDM membrane, or TPO membrane, as we call it. It's a kind of plastic membrane that will be laid on top and then fastened to the deck. So these are all complexities that are within the building, which we never even recognize. If there is a leak in any of this, which I often get involved in investigation, we need to know the exact construction. And if this building is built 30 years ago and there is no details available, then there's a lot of investigative work you have to go through, either cut through the wall, a roof, or a wall, and then locate it. So basically what it implies is that the science and the technology involved is so complex that it requires engineers and real expertise to solve any of these problems. Now, when you look at enclosures, we talked about simple enclosures as single layers, and multiple enclosures now having multiple layers in new enclosures. Now, when you take one of these floors, these can be exposed at the bottom, and this floor, when it goes into the next unit, that could be about a conditioned space. So the way this part of the floor will behave during a winter is very different from the part of the floor that is about here. You often experience this in your homes when your bedroom is about an unheated garage. That room is going to be colder than the rest of the house. So you would either have to have additional heating or have thermal comforters or additional protection if you were going to sleep in the room about the garage, unheated garage. So those are kind of factors that you take into account in designing buildings. Now, we talked of designing buildings in terms of protecting from the weather. But in order to visualize it, you can also use something called computer modeling, energy modeling, thermal modeling. Here is a picture of a wall to roof interface where the outside is cold and the inside is warm, and we can look at how the heat is transferred through this wall. It's simple physics, but it requires understanding the design conditions and then visualizing it so that the right materials can be selected and recommended. Now that gives you a very quick rundown on how the envelope system worked. We can look at similar things in HVAC systems, plumbing systems, and every other systems. I wanted to share this slide to give you a sense of how important and complex the HVAC system in a building is. HVAC, in this case, we refer to this as heating, ventilation, and air conditioning. Now, the heating and ventilation is one critical component in the North American buildings because we often have to protect the indoor environment from changing according to whatever change happens on the outdoor. If the sun shines through the glass around noontime, you're going to have a lot of heat that comes into the room. And then by 5 o'clock, when the sun goes away, the room is not going to be receiving that heat, and it could progressively get colder as the sun sets. And if you have a heating or a cooling system, it'll constantly monitor the temperature in that room and provide either cooling or heating as required to keep that room in a comfortable condition. In order to do that, we have, in larger buildings, we have the thermostats, which are really the control points. We call them thermostats and humidistats. If humidity is of critical importance, you don't see a lot of humidistats in buildings, but generally there is 1 or 2 humidistats in bigger buildings to monitor any excessive humidity that gets returned to the systems. And based on that, they will manage the supply air humidity levels. So the thermostat basically sends a signal whether I need heat or cool. And when that signal is sent, the heating system, it could be either heating on the local zone, or it could be coming from a central system, and it is distributed through ducts. You often see supply registers on the ceilings of large buildings, and if the fan is distributing cold or warm air through that, you'll hear a fan noise. And some people on the corner of the buildings, for example, if there are lots of windows, their corner offices could be hot or cold much more compared to the interior zones where you don't have that kind of variation due to the outdoor conditions, change in the outdoor conditions. So in order to manage all of that, we zone the buildings and we provide different controls for every zone, and they control both chillers, boilers, pumps, and air handlers. These are all components. There is a whole network of pipes that are hidden within the ceilings and probably within walls in many cases as well, where they are distributing air or water depending on the type of systems that are used. Now, this gives you a little sense of how the HVAC system is operating in a building. In a similar way, you have networks for electrical systems. Every plug point that you're seeing in the wall has some kind of wiring that goes through the entire building until the meter outside the building. In a similar way, for plumbing, every washroom, kitchen, sink has a supply pipe and a return pipe, waste pipe. Now, these are all engineered. They don't happen automatically. They have to engineer. Now what we do is create building information models where these are laid out and thoroughly thought through so that there is no clashes between any of these pipes. You have plumbing, you have electricity, you have HVAC. All these three trades have several pipes running throughout the building. So now you have a good sense of how buildings work. Now let's look at what the future is like. The goal of the future buildings is providing a healthy, high quality, livable environment, addressing sustainability, which will be using resource efficient and environmentally friendly materials. We want to use the spaces effectively so that we are not wasting any of the energy or the materials. The next thing we want to do is resilient. We want to be resilient to any of the climate changes or natural disasters that might impact the buildings. And most of all, we want to become, provide affordable buildings. Now, these are the key pillars as the World Economic Forum has identified as the goals for the buildings of the future. You want to have healthy, sustainable, resilient, and affordable buildings. Now, how are we going to achieve that? We see that about 40% of the US energy consumption is consumed in buildings. And that's a very huge percentage of energy, purchased energy. In order to minimize this is where we are promoting energy efficient constructions. So if we can reduce all of this, then we are going to save the energy demands and fossil fuel usage and any carbon emitted to the environment. So there's a huge focus on the energy efficiency aspects of the buildings. The next one is the space. About 30% of the commercial space is now currently wasted. 77% of the time, private offices are unoccupied. And about 60% of the time, workstations are unoccupied. So we needed to come up with some new strategies of how to make our spaces more efficient. And next is about lighting. Lighting, about 45% of commercial lighting cost reduction is through occupancy sensors. We have several ways of controlling the amount of power used for lighting. We can have daylight sensors, motion sensors, timers, and you can combine all of them in such a way that we can minimize the amount of energy used on lighting. Structures, this is where you probably cannot compromise, but you have to look at resource efficient materials to provide the structural strength that we want to accomplish. When you're building a building like Burj Khalifa for about 2,000 to 3,000 feet high, there's going to be limited opportunities other than to use steel. Now, mass timber construction is becoming a lot more common these days, mainly because they are able to offer environmentally friendly materials. So there's a constant challenge in the way how structures will be designed, and that might dictate what type of constructions will be undertaken in a more common construction process. The final and the most important one right now is connectivity. Right now, about 77% of all US nationals have an iPhone or a smartphone. Now, 1 billion phones have been sold in the last, I think, 20 years time is the way they say it. And if we are able to connect all buildings with these smartphones, we are able to do a lot of things which we were unable to do before. So what are some of those things? We will talk about in a few minutes. By 2020, we are going to have 50 billion connected devices. So mobile workers will account for about 72% of the workforce. And all of these mobile devices, every item in the house or in the building will be enabled with an internet connectivity. And that is going to be allowing for automatic sensing of the space usage, the needs of the space, and accordingly manage and control the systems that serve the space. So the energy efficiency retrofits buildings are going to be about 128 billion, it's growing very rapidly, and the opportunities are very huge when you want to retrofit, because the amount of new construction is much fewer than the existing construction. So 50% of all of the building systems and devices will be connected by 2025. This is almost from being 0 10 years ago to 50% in by 2025. And we are expecting that LED bulbs save about $20 billion a year, and they are going to be replacing almost all fixtures in all buildings by 2026. And we expect the energy consumption to increase by 55% by 2030. So on the one hand, population is increasing and the needs are increasing. On the other hand, we have to meet the environmental sustainability requirements and reduce the energy use. How are we going to do that? We're going to do this in using three major components. One is through energy efficiency, and the other is through regulatory enforcement. And then we are also going to come up with innovative designs which will address the challenges of the sustainable design of the future buildings. How can we make a house environmentally sustainable? This is a very simple way to introduce what the steps that one can take to make the home sustainable, and then we can scale it for larger buildings. We needed to look at selecting environmentally friendly materials and construction methods. This is easy said than done. And we have to look at high performance windows, because windows are the huge energy losers, as well as in warm climates could be still energy losers by gaining heat within the building. In the cold climates, they are going to be heat losses, and so they needed to be protected. So we needed to work on high performance windows. Energy saving smart home systems, we'll talk about that in a minute. And energy efficient appliances. If you're ever going to buy an appliance, you'll always look for an Energy Star appliance, right? Or what's the Energy Star score, whether this is an energy efficient appliance. You have a lot of information now provided by the EPA to help you select the right one. And finally, this is now getting a lot more common, which is energy saving smart home systems. These are smart thermostats. Either they are internet enabled or supplied with the system itself. And we also have improved efficiency in the plumbing fixtures, where we reduce the flow rates for showers and faucets. Now, when you look at the home, we are now going to hear this word grid-friendly smart homes. Because what these grid-friendly smart homes do is communicate with the utility using a smart meter and tell them which appliances are requiring energy at what times of the day. And depending on the capacity of the grid or the electricity provider, they could actually send a signal out to either delay or to reduce the power provided to any of this. Now, this is actually much more critical with the introduction of electric vehicles. Everybody, when they connect the electric vehicle, they immediately want them to be charged, or they can start charging at certain times of the day. Depending on the time of day charging, some utilities provide you incentives. In other words, if you charge at night, we'll give you a lower rate. When nobody is using their lights or equipment, we have all the electricity available to charge your car. So that can be managed through this, interfaces, in home controls. These can be enabled either through internet or can be directly wired from the utility to your home. But you're going to see a lot of changes in the next few years in making your home become smarter. It will be using either a smart thermostat. You heard of Nest. you heard of Amazon providing their every one major manufacturer and internet provider is now coming up with some kind of home automation feature, either to control your lights or to control your appliances or to control the heating systems. Now, this takes us to see what the future of the buildings, the future of the residential buildings look like. You will often hear zero energy building, zero energy home. The strategy here is to build most energy efficient homes and operate them efficiently. And for whatever energy that you are not able to either optimize or to minimize, you will use renewable energy to compensate for it. In other words, when we use an electric bulb at night, we need electricity. And in order to get that electricity, either you can generate it using a photovoltaic system or a wind or any other system, and store it and use it when you need it. In other words, there is a net metering system that many of the utilities offer, where you generate the power at the time when your solar panel can generate the power, put it to the grid, and the grid can use that power for whatever other need they have, but they'll provide you a credit with which you can use it at night. So if you use, let's say, well-insulated and efficient components for your building, the amount of electricity that you will require for this building will be low enough that the PV production will actually meet that need. By that, you will achieve zero energy. We call it as net zero energy because your building is still using energy, but you are generating energy using your photovoltaic so that your net energy use of the building is zero. So you're going to see often people call them as net zero energy or net zero carbon, so that the total production is actually minimized or reduced to zero. In the homes, it's a little bit easier to understand, where you have insulated components for your envelope, efficient equipment for your heating and cooling, and LED lighting, along with photovoltaic. We can achieve a net zero building, a net zero home. In the residential, in the commercial building, it becomes a lot more challenging. It is not that simple or straightforward, and it is also a very complex combination of systems. So we're going to rely on building data networks to provide all of the information and control data that will be needed for the facilities network. So there's going to be two sets of networks in these future buildings. There's going to be a building data network and then a building systems network. The systems network will help you, for example, security, where access control will be provided through it. And if there is going to be any intrusion or any breakage of glass, that can be automatically deducted, communicated through this to whoever that needs to take action. Similar things can happen for the life safety. And for lighting, we have schedules. We can also set scenes as occupied, unoccupied, holiday, that kind of scenes, and then say which light should be on and which light should be off. We could have automatic shades, and these shades can be controlled using the same kind of light level sensors. If there are people, then you can use them using occupancy sensors. So those are sensor control lighting. Elevators, for example, if you are entering a building and you have a proximity card or a phone with you, elevator will really come down to the floor where you are. And once when you enter, it will take you to the floor where you're authorized to go. So the elevator controls can work similar to what the lighting controls work, but this is going to just automatically sense based on the proximity cards that you're provided. So you're going into a building automation where data and networking is going to drive a lot of functionality in these buildings. HVAC, I think we have talked about quite a lot, and I don't want to go further in there. Both HVAC systems and energy management going to be very critical because we want to reduce the amount of energy that's used in the buildings. If you go into larger buildings these days, they provide you energy dashboards where the occupants of the building really look at what the building energy use and the carbon footprint of the day for that building is. And this helps people change their behavior with, let's say, resetting their thermostat or turning off their lights or computers and others. There's a lot of monitoring that also goes on for alarms and notifications, maintaining the quality and durability of the materials and others. Okay, so building automation and smart buildings are the way of the future in order to meet the energy and sustainability goals. What we haven't talked about in larger buildings is how they will meet the renewable energy goals, because you don't have a lot of room here for photovoltaic. And so what the options here are to use what we call it as free energy, using either using the outdoor air when the temperature of outdoor air is closer to what the indoor air requirement is. So we have economizers, and then we can control the heating and cooling systems to avoid using fossil fuel and just bring in natural ventilation into the building to minimize the fossil fuel use or minimize the use of the mechanical systems. You will also hear a lot about geothermal heat pumps. Heat pump technology is the most prominent technology right now coming to market, both in the residential and in the commercial buildings, where heat pumps try to use heat recovery from the air, earth, or water, and use free energy to provide conditioned air for the buildings. Now, this is all quickly changing, but the good news here is that a lot of technology development is currently underway, both in the building data networking, facilities networking, and in the equipment efficiencies. Now, to summarize, we'll say buildings are complex integrated systems. If you ever thought that building is just a very simple thing and took it for granted, hopefully this presentation gave you an appreciation of what goes on into designing, constructing, and operating a building. And throughout our discussions, we always thought that buildings operated without needing any automation. But in the last 10 years, we have seen about 50% of building operations are controlled by Internet of Device and components with building network data networks. You're going to see more of that happen in the future, and it's going to be a very critical component. A lot of smart home technologies and smart building technologies are making their way into buildings. Now, the buildings of the future will be healthy, sustainable, resilient, and affordable, as I covered in the previous slides. But each one of these requires very dedicated group of people focused on making sure that the design and the construction and operation really address these issues. You're going to see decarbonization, net zero energy, net zero carbon, carbon neutral. All of these are terms that you will hear as primary goals of future buildings. There are LEED, which is leadership in an energy and environmental design, well buildings, which are meant for healthy buildings, and there are several other frameworks that are currently in the industry to make sure that future buildings are energy efficient. The government and even the industry is requiring ESG goals, or energy sustainability and governance goals, that's going to change the way we design and operate buildings. So the opportunities are plenty for everyone, and we have a great way to make an interesting and healthy building. I wish you hey, Daisy, I will stop here, and if there are any questions we can take, otherwise, I think we can end the seminar here.
Okay. Thank you, Krishna. It was really fascinating. So many things go into that building technology nowadays. If anybody has any questions, please post it on, and questions are this tab, and our Vinay is also monitoring our YouTube. We apologize that we had little starting trouble in getting the YouTube channel working, and then now it's going through fine. The question I have is, Krishnan, that we're talking about zero carbon and zero energy and all those things. So, is it specifically due to the climate change and warming of the on the planet? Is there any special
global warming?
Yeah, global warming. Where any special directions you were all focusing on to combat or make it a little bit more comfortable?
So I think when we look at design, it always comes from the owner's perspective. Okay, the owners don't want to spend any money, right? If you spend $0 for your energy, you're happy, right? So they want to reduce the energy cost of operating the building. So our goal is mainly to find ways to make the building efficient to reduce it. Getting to zero is going to be very hard. The environmentalists want to reduce carbon. So the metrics that we have, I didn't put net zero cost, but there is net zero cost, net zero energy, and net zero carbon. So those are the three real metrics that are currently used in the industry. Environmentalists and homeowners and everybody want to save the environment. They don't want global warming, or they don't want to, impact the environment. The owners, they want to not spend any money at all. If they can spend very little, they'll be glad, and they want to see net zero cost.
Mm-hmm.
From the government perspective, they want to avoid borrowing oil or fossil fuel, and they want to reduce the energy, so they are focused on net zero energy. So we have three competing interests. Now, unless we put in new, let's say, renewable generation on the facility, we cannot bring it to net zero. Now, in order to bring that renewable, you have to put cost, or you have to invest in it. So the first cost is high, and owners say, you know what, I'll pay the extra that you need every year to maintain the building, and I can't put in $300,000 for the photovoltaic panel for this, or I can't put that expensive for this, improving the system. So there is a competing interest between first cost and operating cost from the owner's perspective, the reduction of energy from the government perspective and regulatory perspective, and their goal is to say, okay, we're going to enforce energy codes that you cannot get approval for your building unless you meet a certain target. So they set energy targets. And then we have these homeowners that want to have healthy buildings, and they don't care about cost or the energy. So all they care is, we don't want to impact the environment, but we want to have healthy indoor environment. So you have these three major goals. When we work with architects, our main goal is to really meet the regulatory requirements. So we are working on providing net zero energy, or providing minimal energy use, because net zero energy as it's currently required is not practical without renewables. And renewables require investment, and not any building owner is interested in providing that investment, or interested in knowing all of the options for that. They want quick, immediate, answers to the problems. So we are currently focused on that aspect of making sure we are providing energy efficient construction. Architects are more interested in providing the healthy building, which is their client needs. So they are focused on resource intense or less intense materials. I don't know if that answered the question.
Yeah, definitely. Yeah, That's, and at least from what I understand, it's more to do with the enforcement and the large builders initiative rather than the individual homeowners.
Right.
And one of the questions I have here is, what made you interested in this career? Is there any anecdotes?
So it's, yeah, no, I think that's I did reflect on this quite a bit before. I'm a civil structural engineer with minor in architecture. So when I came to study, I was very interested in doing anything that I can do with computers. So I did create something called passive solar glazings in structural roof systems. And that's when I got introduced to the energy efficiency topic. I still am a structural engineer by, degree. So I was integrating passive solar glazings on folded plate roof systems. And I was doing analysis of the structural systems, but I had to learn how the glazings got integrated to the roofs. If you look at industrial buildings, you see sawtooth roofs, and one part of it, they will have glazings where it allows light into the building so that they don't have to have daylighting in the building. So during 1970s, when the oil embargo was there was a big push towards energy efficiency. And I came to do research for a structural engineering professor. And in order to get my research funding, I had to do something related to energy efficiency. And that's how I got introduced to energy efficiency. And it so happens that career in energy efficiency and computer applications took me this way than my original engineering and structural engineering. Structural engineering was easy there were a lot of people, licensed structural engineers here, but not a lot of people who could do structural and energy efficiency. So I ended up focusing more on the energy efficiency side. And I, as a civil structural engineer with minor in architecture, I was very passionate about the enclosure, and so I do all my life right now on enclosure design and enclosure investigations. Yeah.
And that was really good because you had a leg up in the future even before people realized that we need that to be done. So
I don't know that. All I know is that I needed to get my stipend to do my research.
But it turned out to be a good thing to happen.
Yeah.
My own question I had was, nearly 20 years ago when I was building my home, the internet was craze. So I ran through a lot of these Cat5 cables through all the buildings and all the sound system cables through my building and everything. And by the time I finished building and then started occupying, internet became wireless with Wi-Fi, and we have Bluetooth speakers all over the room. So I never used any of those things. Even my security system, I never used wired ones. Since then, and it all turned out to be, by the time the technology was changing so fast,
rapidly.
You have any tips for our future builders to don't waste your money in this or start looking at these things?
Yeah, no, I did my first home automation design in 1991, and it is very similar to what you are currently stating. We had to have separate communication wiring, or we call it as power line communications, PLCs. In other words, we needed to have filters so that we can do communication on power line. This was 1991. So we did control all of the lighting system controls using those. But the amount of additional work was so much, and the maintenance is so much. 20 years later or 10 years later, all of them were decommissioned. So all this wiring that we put in, like what you put in for Cat5 or even cable, for example, in many homes, if they ran multiple cables, one for communication, one for speakers, and one for telephone, you have multiple cables running through this. Now, with the Internet of Things and with the current approach to communication and everything going wireless, we are going to have only power to be delivered to every room and none of the others. You don't even need telephone cables anymore. We are not going to be relying on that at all. So I think they're going to simplify the future and also provide you more flexibility. Now, what the downside of this is, every time a homeowner changes and another homeowner takes your home, they have to re-establish their home networking. And it could be with a different provider, it could be with a different technology. You may be an Apple person and the other person coming in may have completely a different system, or an Amazon Alexa, for example, they can use to control it, or Google Home they could use to control it. And so you're going to see this industry constantly evolving, and making any permanent changes to the home in order to do this is not really going to be worth it anymore, other than anything electrical. If you have an electric vehicle, for example, you need it to have a 220-volt charger, and if you have to install it, there is no option for it. But if you're going to put another room with speakers and you want to run wires, go with the Bluetooth way. That's, yeah.
Yeah, it rapidly changes. So one last question I have is, for the older homes, more than 20 years old or something, what is the quickest and the cheapest or the best improvements you can make to be an energy efficient home?
So my own personal example was to buy a Nest thermostat or any other EcoHome or Ecobee, I think it's called. There's any thermostat that you can get, depending on where you live in the country. Thermostat, smart thermostat is one of the first investments that you can make. Utilities provide you the rebate for it, and they have options to integrate with every legacy mechanical system that's out there. So they can control these mechanical systems easily. I did it as a do-it-yourselfer, and I can tell you that in Seattle, when I changed our old Honeywell, thermostat to a smart thermostat, the cost saving was more than 30%. Every 1 degree that you reduce or increase has an impact on the energy use. So you needed to have setback temperatures that you can use, or learning thermostats, which use the occupancy conditions to control the supply of heat and cold air. That will help you with reducing immediate energy savings. The second one I think you need to look at is the lighting controls. A lot of light switches now can be attached with smart controls. EcoHome has it. You have Google Home provides options for it. Alexa also has. Amazon has provided some as well. So you can do lighting. So I will recommend people to look at controlling heating and cooling first, lighting second. That will be the two places where you're going to see immediate energy savings. And every appliance you're replacing after 5 or 10, 15 or 20 years, you got to look for the most energy efficient appliance. And if it can be internet connected, then you want to have it internet connected appliance so that you can control it. There are several benefits of internet connected appliances. One is to check them remotely as to the status of them. And second is to also schedule time of operation of that. So you save a lot of energy with connected devices.
Yes. Yeah, thank you. I'd like to touch with Vinay. Is there any questions in the YouTube side or?
No, there's no questions on that.
Okay. Okay, we have to figure that out. I'm sorry that we had stumbling in the beginning, and then we have to figure out how they can post questions. But thank you so much, Krishnan, for spending your time and coming up with this little bit different type of webinar we have been doing all this time. But I hope everybody had a great glimpse of the building technology or the future and a view of know where we live and what we do and all those things. So thank you very much for your time, energy, and also patience in answering your questions. And then we will send you the presentation material link by tomorrow to all those who are here. And also, you could see it in the YouTube channel, the presentation. And we conclude here. Yeah, go ahead.
Subscribe to the channel so that I think also as part of the so all the presentations that we have will be posted on our YouTube channel, and also subscribers can post the questions on the channel. That's what we saw as the configuration. So please subscribe to North South YouTube channel.
Yes, please. And then we will continue to experiment with this simulcast for next few sessions and see how we go about before we turn on to Facebook or anything. But I thank you very much for doing it. We will join again in 2 weeks. That time we are going to have a little bit different topic. It's going to be on the personal finance side with a lawyer and a financial advisor talking about wills and trusts and probates, which is a very popular subject, and people are asking for that. So it'll be on 29th of June, Saturday, 2 weeks from now. Please watch for our announcements, register and attend the session. And before you leave, fill in your feedback. And thank you once again, Krishnan. And then we will be in touch with you for any future sessions. And then
thanks, Daisy.
Yeah, thanks,
I hope
Vinay.
I inspired people with some interest in building.
Absolutely. Yeah.
Bye. Have a good summer, everybody. Bye.
Bye.
Thanks, Daisy. Bye.